everyone, thank you so much for coming to this video. So today we're going to be going over how to calculate the magnitude and direction of a vector. So please review the previous video on introducing vectors, as that will come into use for this video. Also make sure you know how to do Pythagoras theorem and also trigonometry, as we'll also be using that. So the learning objective for today is to be able to calculate the magnitude and direction of a vector, and also to be able to convert between component and magnitude or direction form. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. Okay, so I've written out the main points that you need to know for calculating the magnitude and direction of a vector. So in general, if you have a vector in the form xi plus yi, then you know that its magnitude r is equal to the square root of x squared plus y squared. So that's just using Pythagoras theorem. So if you see here in this diagram, let's say we have this vector a, and then you can break it up in like its components. So a would be in the form xi plus yj. So then in order to work out the direction, you just use Pythagoras theorem. So you know that a would just be equal to, so the magnitude of a would just be equal to square root of x squared plus y squared, just using Pythagoras theorem. So like there are two ways to write the magnitude of a vector. So you can either write, if it's just a, then it's just like the mod of a, like that mod sign of a, like I've written here. Or if you had like a vector connecting a to b, then the magnitude of AB would be the mod of AB. So that's magnitude, and you could also say magnitude, you can give that as a symbol of r. And then you can also say that your vector can make an angle theta with the horizontal. So if this is your vector, then it would have this angle theta, and that would be equal to the inverse of tan y over x. So that's because if you were to find out what this angle theta is, and you know what your side x, y is, you know that tan theta is just equal to the opposite, which is y, over adjacent, which is x. So theta is just the inverse, tan inverse of y over x. You can write out, to convert between component and magnitude and direction form, if you know your magnitude and direction of a vector, but you don't know your actual x and y in front of your I and j, then you can work out your x as just being r cos theta. So that's because if you were to work out your x, you would say that, so you know your r is your hypotenuse and your x is your adjacent, so you could just say that cos theta is just equal to adjacent, which is x over r, so that means x is just r cos theta. And similarly, if you were to work out your y is your opposite, your r is your hypotenuse, so you could just say that sine theta is equal to the opposite, which is y over your hypotenuse r, so that means y is just r sine theta. So yeah, so that's how, if you know your component form, which is just you don't know your component form, which is xy plus yi, but you know your magnitude and your direction, then you can just write your x as r cos theta and your y is just r sine theta. And the last thing you need to know is about a unit vector. So if you're asked to find a unit vector in the direction of a, then your unit vector a is just equal to your vector a over your mod of a. So that's just using the fact that your magnitude of your unit vector has to have magnitude 1. So that's everything you really need to know about calculating magnitude and direction of a vector, and how to convert between component and magnitude or direction form. So let's try apply this to some questions. So we've got 3 questions here. Let's start with question 1. We want to find the unit vector in the direction of a equals 5 plus 3j. So feel free to pause the video and attempt it yourself. So in order to do this, it will be helpful if we can draw a diagram. So we know that if we have a vector a like this, then you know this it goes in the x direction of 5 units and in your y direction of 3 units. So it's a right angle triangle. So we can work out our mod of A using Pythagoras. It's just the square root of 5 squared plus 3 squared. And if you plug that in your calculator, that's equal to 5.83. So that means that your unit vector A is just equal to 5i plus 3j over 5.83, which is just the same as 1 over square root of 34 of 5i plus 3j. So that's all you have to do to work out a unit vector. So now let's move on to question 2. Again, feel free to pause it and attempt it yourself. So we have the acceleration of the body is given by the vector A equals 6i minus 2j. We want to find the magnitude and direction of the acceleration. So the first thing you want to do is just want to draw this vector out. So it goes 6 units in the x direction, so it goes something like this, and 2 units in the negative y direction, so it would go down by 2 units like this. So it would have 6 and 2. So your vector A would look something like this. So now we want to find the magnitude of this. So we could just say A, just again using Pythagoras theorem, is the square root of 6 squared plus 2 squared. So that's just equal to the square root of 36 plus 4, so it's the square root of 40. And then now we want to find the direction. So the direction is always the direction theta is always with the horizontal. So we know our horizontal is this 6, so the direction of the vector is just this angle here. So we know our opposite adjacent here, we know our opposite, so we could just say tan theta is equal to opposite 2 over adjacent 6. So our theta is just tan inverse of a third. And if you plug that in your calculator, that's equal to 18.4 degrees. So that's this angle theta here. However, the direction is always measured anti-clockwise from your positive x-axis. So your actual angle that you want to measure would be from your horizontal anti-clockwise to here. So be that angle, not the little one we have. So your actual theta, so your direction is actually 360 minus your 18.4, which is 341.6 degrees. So that's, we have our magnitude as square root of 40 and we have our direction of 341.6. So just remember this direction that we have here is always measured anti-clockwise from positive x-axis. So just remember that, as a lot of people would trip up. So this is just the angle from the triangle, but we need to get from the positive all the way anti-clockwise to where our line is, and then that's your direction of your vector. So the last question we have here is: a board is travelling at 5 meters per second at an angle of 30 degrees to the horizontal, and we want to find horizontal and vertical components of the board's velocity. So if we have a horizontal like this, then remember anti-clockwise, so it could be, have it like this, so 30 degrees like this, and this is our vertical, and it's saying it's traveling at 5 meters per second, so that's your magnitude of your velocity. So this one is 5. So we want to find out our horizontal and vertical components. So we know here, we know our R is 5, and we know that our theta is 30 degrees. So we know our magnitude and our direction, so we can use this form here. So we could say our horizontal is just r cos theta, so it'll be 5 cos 30. And if you plug that in your calculator, so you can plug that in calculator, you don't need to, let's just leave it as 5 cos 30. And then our J form, our vertical component would be r sine theta, which is just 5 sine 30. So that means your velocity is just equal to 5 cos 30 I plus 5 sine 30j. And that's your answer to this question. So this one was just, again, draw the diagram of your magnitude and your direction. So they've given that to you, so you can just use this form here. That if you know your magnitude and direction, you can write your vector in the form r cos theta I plus r sine theta j. So that's everything we wanted to cover. So now let's move on to an exam style question. So we have an exam question here. Feel free to pause the video and try it out for yourself first. So we have given that the mod of 2i minus kj is equal to 2 root 10. We want to find the exact value of k. So it's saying that the magnitude of the vector 2i minus kj is 2 root 10. So therefore we can rewrite, let me do this simply, we can rewrite mod of 2i minus kj as just the square root of 2 squared plus minus k squared is equal to 2 root 10. So now we can just solve this algebraically for k. So if we square everything, we'd have 4 plus k squared is equal to 4 times 10, so is equal to 40. So therefore k squared is just equal to 36, because that means k is equal to plus or minus 6. And that's answers the question. So quite simple, just using Pythagoras theorem to find what k is. So that's everything. Thank you so much, everyone. Hope you found that useful, and you can now calculate the magnitude and direction of a vector and can convert between component and magnitude or direction form. So make sure you do some practice questions just to make sure you've fully understood everything that we've covered.